Hello everyone, welcome. Yes, so this is going to be a live demo of like 60 minutes worth of code. There's no chance anything could go wrong whatsoever, so hold on to your seats. Right, I'm Trisha, I work for JetBrains. JetBrains are the company behind Kotlin and also IntelliJ IDEA. Surprisingly, I actually don't know that much about Kotlin because I've been here for 5 years talking about Java and IntelliJ IDEA, which is my usual thing. But Josh Long persuaded me to put this presentation together with him for Code 1 last year. So it's got obviously Spring Boot and Josh Long type stuff in there and Kotlin and JavaFX. And he said, like, for this presentation, why don't you just do it on your own? So I'm now doing all of Josh's Spring Booty stuff as well, even though that's kind of his thing. So what could possibly go wrong? So yeah, let's just crack on. There may be time for questions, there may not. It really depends on how much live debugging we're going to be doing as we go along. The application itself is it's a fairly simple one. We're going to have a back-end service which is emitting stock prices and a front-end application which is written in JavaFX which is going to be responding to those prices and drawing stuff on a chart. So it's just basically a client-server type application. So the first thing we're going to do is we're going to create a Kotlin RESTful service using Spring Boot. So let's just go straight on and try and do that. I'm going to create a new project. Obviously, I'm going to be using IntelliJ IDEA because otherwise JetBrains would fire me, but also because it's just amazing. So yes, so we're going to do a Spring Initializer project. I'm going to put in the group name. Let's say it's a stock service. And I'm going to use Java 11. Which version? Who's using Java 8? Who's using Java 11? Okay, that's surprising. Two lots of Java 11. Okay. Highly recommend you look into moving to Java 11 for complicated reasons, but anyway, that's not the topic of this talk. I have other videos on that. Right, so this is the Kotlin service. And let's just go ahead. We're going to use Webflux. And I need to use the release candidate for reasons that should become clear later on. By the way, so I'm using an early access version of IntelliJ IDEA 2019.3. I'm using the release candidate of Spring Boot. I'm using Java 13 under the covers, and I'm using something else which is early access. So like nothing could possibly go wrong with this combination of new technologies. Let's just see what could go wrong. I'm not nervous about this talk at all. Right, so we've got our classic Spring Boot application. We should have all the normal stuff which comes in. Like I said, we have got some tiny teething things with the new version of IntelliJ IDEA, but that's fine. We just need to make sure it recognizes it as a Maven project. Okay, fine. So as usual, we have our Spring Boot application, but we're not going to use that because we want to do something in Kotlin. So let's create a new Kotlin class. We're going to call it service application. And Kotlin is not configured, so we just get IntelliJ IDEA to fix everything for us. Let's just say go on, do that. So we've added all of the Kotlin stuff that we need. I will come back to this in a minute because we need something else. I'll get Maven to just keep importing stuff when things change. Okay, so I need a new class. This is going to be my Spring Boot application. So at this point it says that it needs to be open basically, but what we're going to do is we're going to add another magic incantation to help us with Kotlin and Spring, which is, I'm going to compile it to Java 11 just because I can. Compiler plugins, we need to add a plugin for Spring. I am going to go quite quickly through this because I've got quite a lot of content. You can play back the video later at a much slower speed and see what's happening, or not, depending on how much you get out of the session. Okay, so this error goes away because now we've got some Spring helpers in our Kotlin compilation. I need a main method, so I'm going to generate one of those. I'm going to run my application, which is my service application. I'm going to pass in my arguments. Okay, so this is my Kotlin version of the simple Spring Boot application. I'm going to run it just to see that hopefully it doesn't error. It's not going to do anything yet, obviously. So it kind of looks fairly familiar. Who is kind of familiar with Kotlin? Okay, so for many of you this will be, well, for some of you, you kind of got it. For some of you, this is the first time you've seen it. I'm not an expert on Kotlin. I've just been dabbling with it. I quite like it because it's kind of familiar for Java programmer like me. It's not too high maintenance to get started, and you'll start seeing some of the interesting features. So what I want to do is I want to add a REST API for this stuff. So we're going to have a REST controller, which is going to be I'm just going to call it REST controller. And I want a method, or a function. I'm going to call it prices for, and this will return the stock prices for a given symbol, which I have not spelled correctly. The symbol is a string, and we're talking reactive, so I'm going to return a flux of stock prices, stock price. So let's import flux, and let's create ourselves a stock price. I'm just going to put everything inside the same file because it's a bit easier for demo purposes. Now this is going to be a data class. This is one of my favorite features of Kotlin. Oops, that's not what I want to do. And this basically means that I don't need getters, setters, toString, hash code, equals, any of that nonsense. All I have to do is say, what properties do I want on this thing? So I want a symbol, which is a string. I want a price, which is not stock price, it's a double. I want a time, which is local date time. And then that's all I need to have like a simple data class with all my, just built-in getters and setters. Now, what I want to do is I want to return a flux of these things. So what I'm going to do, just for the purposes of this demo, is I'm going to create a flux which is ticking once a second. So interval of 1 second. So it emits something every second. And what it's going to emit is it's going to emit a stock price. So I say stock price. And because this is Kotlin, I don't have to say new. And until I started programming in Kotlin, I didn't realize how annoying it was to use the new keyword everywhere, because it's just 3 characters, but it just makes life a bit easier. So I want a new stock price with my symbol. I'm going to say generate random stock price, or let's just say price. And I'm going to have a local date time of now as my time. So let's create this. What does this do? Let's create a function that generate random price. This is going to generate a double. Let's put that so we can see it. And this is going to be thread local random generate me a double. Obviously, this is not a real set of stock prices. This is for the purposes of the demo. But this is what we're going to do, generate a random price each second. So I need to return this. I need to return this flux. And there's a bunch of other stuff you can do with this flux object. That's kind of the point, is that you can do all sorts of things on here. One of the things I might want to do is share it amongst multiple consumers and all sorts of things. But for the simplicity of this, all I'm literally going to do is just have something which emits a new price every second. So now if we run this, it might, oh no, that's not going to work, because obviously I need to say where to get this thing from. So I'm going to say get mapping, and it's going to be, we're going to put it on stocks symbol, and then just get IntelliJ to wrap that up for me. This thing produces media type of the text stream value. This is the reactive stream thing, basically. It's just going to create an infinite stream of prices which I'm going to subscribe to. All right, let's just check I've done that right before I start anything else. I need this here. Oh yes, so I need that here. And also I'm just going to get IntelliJ to fix this for me because I need to create this as a path variable. Okay, so let's start that. If anyone else has seen anything else wrong before I go through the long cycle of restarting everything, I am welcome to. This is basically like pair programming, but with like 150 pairs. Okay, so that started, and then hopefully when we refresh this, we'll see, as you can see now, here's the prices ticking over every second. Okay, and it's got a randomly generated number and a time and so forth. Okay, so hopefully you get a feel that from a fairly limited number of lines of code, we've created a Kotlin service on the back end. We will come back to this service later, but this is the basic that we need to start building up our user interface. Right, so that's done. So now we're going to create a chart that's going to eventually look at these prices and chart them in real time. So I want to create a new project for this because it's basically an entirely new project. And I want to keep it obvious in our mind what's on the client and what's on the server. This is going to have two different modules. So I'm going to create this as an empty project called stock client. And then I'm going to create a new module, which is a Spring Boot module with Java 13, because I'm hip and groovy, and Java 13 only came out a few weeks ago, so what could go wrong? And this is com.mechanitus. This is stock client, stock UI. And then we're going to use 11. And this is the JavaFX bit. We want the Webflux stuff here as well. And again, we are going to want the release candidate in a minute. So that's all good. Let's do this. Make sure everything's set up properly. Make sure it recognizes it's a Maven project. Normally, IntelliJ picks this stuff up automatically. It's just, I'm going to have to speak to the people and make sure that's working. It works in 2019.2, 2019.3, it's not so much. Anyway, so this is my user interface. This is not a web user interface. The first thing I want to do is I want to say this is not a web app, okay? At the top, in case you hadn't noticed, I'm having it flash up the keyboard shortcuts that I use because I use a lot of shortcuts to try and get through this as fast as possible. Unfortunately, it means that sometimes it flashes up on top of the thing I'm trying to write. But that's fine. It's just like having to see two things at the same time. So this is not a web application. This is going to be a JavaFX application. So what I'm going to need is I'm going to need my JavaFX application. Let's create one of these. I'm going to call it chart. This is going to be Java, not Kotlin. Chart application, which has to be a JavaFX application, which means we need to add our Maven dependency on JavaFX graphics. Get Maven to build itself automatically and import JavaFX. Okay, so again, as per usual, because I'm really lazy, I just get IntelliJ IDEA to generate all the stuff that I need for me. We will come back to this application. This is the root for JavaFX applications. So we have a slightly complicated thing when we're trying to start up JavaFX applications sort of wrapped inside Spring and Spring Boot and trying to use those two things together. To initialize them, we kind of basically have two entry points, which for reasons which basically involve Java 9 and the module path, we have to do a slightly complicated thing. But that's fine, we just do it once. So we're going to run from application, which is our JavaFX application, we're going to launch chart application, .class, and pass in our args. And in our chart application, our chart application needs to be our Spring Boot application. All right, now what we want to do is we're going to try and do this in like a Spring Booty kind of way, rather than doing, normally when you're looking at JavaFX stuff, there's quite a lot of sort of manual wiring stuff together. We don't want to do that. We want to utilize some of the features of JavaFX to do this, of Spring to make things a little bit easier for us. So first thing we're going to do is this method start will be fired once it's started up and created the stage, which is the thing we're going to put the UI on. So what we want to do is, let's say application context, we want one of these. We'll have it as a field, it's a configurable application context. I'll set that up in a minute. And then I'm going to publish a stage ready event with my stage. Let's create one of these. Let's have an inner class. This will not be private because we're going to need to listen to one of these events. might be static. Okay, so we're going to publish one of those events. And then that means we also need to set up our application context. So we're going to do that in the JavaFX world. We need to do that with an Init method. And so we need a new Spring application builder with chart application every time. And just assign that to our application context. Okay, so we've done initialization, setting up our application context. We also need to do a teardown because that's the responsible thing to do. So we are going to override our stop method. So we're going to close our application context. And we also need to tell JavaFX to finish what it's doing. So this class is basically the sort of initialization, setup, and teardown of the JavaFX application, and also helping to wire into the functionality of Spring that we don't normally get from inside JavaFX. Okay, so we need something to listen to this application event. So what are we going to do here? Let's create ourselves a chart initializer, which I'm going to spell the American way, which always trips me up, which implements ApplicationListener. And we're listening to the stage ready event. Let's import that. Implement our methods. So what do we need to do once our stage is ready? Well, firstly, we need to get the stage. So let's get our stage. We're going to create this method here. It's going to return me a stage, which is my, oops, not get stage, because I haven't written that yet. Get source. I know my source is a stage, so I'm going to cast it to a stage because that's what this is. Okay, so I'll just cast that, and then I know what I've got. If I have a stage, what do I need to do with my stage? The stage is where I'm going to actually set up the user interface. So my stage, I need to set a scene. So let's create a scene. Let's create a scene. That means something different in English. Let's create a scene. I want a parent, which we'll create in a minute. I'm going to set up my height and width. The parent will need initializing. We need an fxml loader, and this will allow us to read fxml, which is where we're going to initialize which is where we're going to create the user interface. So let's import one of these. fxml loader, fxml. This takes so this is something that I changed in the demo this morning, because what you need to do, like when you've spent 3 weeks creating a demo, is to change something 20 minutes before you give it, so you can't remember what it was you were doing. I need a chart resource, because I found a more springy way to do something, and I thought that was kind of fun. So this is going to be a resource, and then I'm going to get the URL from there. And my chart resource is what? It is it's on the class path. It's going to be something called chart.fxml. What could go wrong? Right, let's surround things with a try catch. Let's do the responsible thing. Yeah, let's throw new runtime exception. This is not how you do error handling in production. This is how you do error handling when you're doing a demo. Right, so this is all kind of involved JavaFX stuff, but you only need to do it once. This is my fxml loader, and then when I've got one of those, then I need to, this will tell JavaFX how to get the pieces and glue them all together. Now, obviously, one of the things you want to do is make use of the application context that you have with Spring. So we're going to tell fxml loader that we can use Spring to kind of create things that we need to create. There's a lot of magic in here, though, so sometimes the compiler goes, I'm not really sure what you mean. So let's see if we can get it to work. Application context. We need one of these. We need it as a field. Application context. Add that to my constructor. Note that I do not type this stuff. I use the IDE to do all this stuff because it's too boring to type it all. So we're going to, if we need something, we're going to get it from the application context. The IDE is going to give me an error, and then mysteriously, when I paste the same in, it does not give me an error. I don't know why I will be raising tickets for this. Oops, sorry. Right, so now my parent is easily done by just saying, load me this. Again, a lot of this is just kind of magic incantation. Now we have our stage, which has the scene, which is going to be built from stuff from our fxml. Then obviously we want to show this. And we also need one of these, otherwise we're going to get an error. So, which is something I get all the time. We need a fxml file, chart. And we're going to have a chart controller. We'll get IntelliJ to create one of these for me because I'm too lazy to type it. And we also, I don't want this. I do want this to, for now, I'm just going to put a placeholder in here. I'm just going to put a box. And hopefully, there's an awful lot of hopefullys in this. When we run this, it should work. When I say work, it will flash up an empty box, because obviously we haven't tied anything into the back end or put anything on this box. But we want to verify stuff as we go along and make sure things haven't gone horribly wrong yet. Which bit have I forgotten this time? Something really important. There's nothing there. Okay, that's nice. Now this becomes an exercise in debugging. My chart controller, well, I don't need one of those yet. Yes, I do. This needs to be a component. What else have we got? That's an application. This is a component. And otherwise, just randomly add Spring annotations to stuff and see if it starts to work. I don't know if anyone else has ever done that. Right, let's see. Ta-da! Oh, I'm so happy. That's exciting. Okay, I know there's nothing on here, but you know, it's good when something appears. Right, so now we've done that. We have the basics of the user interface. Obviously, what we want to do is we want to connect to the back end and consume this reactive stream of prices and do something useful with it. So the first thing we're going to do is going to create just the client code to connect to the back end to prove that that works before I start wiring anything into the user interface. So I'm going to create a new module for the client code. Another Spring module. This is going to be stock client. I'm going to use, I'm using Java 11, but I'm not actually using any of the features from here yet. What we want for this is, again, we want the reactive stream stuff, and I'm also going to use Lombok, and I'm going to use the release candidate again. Okay. Make sure IntelliJ knows about the Maven project, and then start working on this one. So I've put it as a separate module because this is basically going to be client code that could be used for anything which wants to connect to it. So the fact that I happen to have a JavaFX UI, it doesn't have to be JavaFX, it could be anything else which uses this code to connect to the back end. So that's why I've separated those things. I don't need one of these because this is not an application. This is going to be configuration code, basically. What I'm going to do is I'm going to test drive this, because I think having a simple test is a good way to make sure that stuff is working before I start trying to tie it all up together end to end. So I'm going to start by trying to create a web client stock client, which the repetition hurts me, but this is what it will be. I'm going to create a test for this. This is going to be an integration test because I need to have the server running at the back end. Okay, I'm going to create a test method called should work, because that's the important thing. I want a new web client stock client. What do we want this thing to do? So this is where I'm doing some TDD type stuff. What do I want this to do? Well, I want to be able to get the prices for a specific symbol. So let's create a symbol. This is a string. It doesn't really matter what it is for the test. Let's create this method. I want this to return a flux of stock prices because that's what we're trying to do. This is the reactive streams thing. So I want to create one of these. Now, we created stock price, but we created stock price as a Kotlin data class on the back end. We need to create stock price as some sort of class on the Java client side. So we're going to create one of these classes. We're going to use Lombok so that it looks a little bit like the same thing we had on the server. I will come back to this class. And for testing, because we're going to do this incrementally, we're going to create a flux from array with new stock price 0, just to make sure that the test works. Let's just do a really dumb assertion. Assertion.assert that we have some values in here. So that is a really silly name. Let's call that prices. I want to just take 5 of them, and I want to see that I have 5 of them. Let's run this and see what happens. I expect this to fail because I'm not returning any prices, but I want to create the infrastructure so that we can start testing the thing properly. Hopefully it should fail for the right reasons. Yes, we expected 5, we got 0. Fine, that's good, because what we haven't done is we haven't done anything here. We're in the client, we now need to connect to the server. So we're going to connect to the server, as mentioned by the title of this class, using a web client. Let's see, what's the best way to do this? Let's create it as a field. And let's inject it. Okay. What do we need to do? Well, we know where we need to connect to. We need to connect to local host 8080 stocks. Was it called stocks or stock? Stocks symbol. Let's give it the symbol. What do we want to do with this? We want to retrieve it. We want to turn it into a series of stock prices. And there's a bunch of other stuff you can do here, which is the nice thing about using these reactive APIs, is we can do things like define our retried backoff. We can do things like define our, what's it called, on error do stuff. I'm not going to do any of that for the purposes of the demo because there's only so much time. But the point is that this is the nice thing about these APIs, is you can kind of chain together to design how you want it to behave. So we want to return one of those. I'm going to get rid of this because we don't need it anymore. And then somewhere in the test, we need to also create our web client. So this is going to be there. Now, if we rerun, we should be able to get at least more than 1. Let's see what's happening. Okay, this looks promising. We have decoded a bunch of data. We got at least 5. And what we have here is this is the data that was on the wire, and we ended up with a stock price object. The stock price object doesn't have anything in it because we didn't do anything with it. So the other thing we need to do is add our fields here. So private string symbol. It's the same as we had on the other end. Private double price. Private local date time. Time. And now when we rerun, we should see that we have a fully populated stock price and all of the serialization has been taken care of for us. All right, let's see. Yes, so now we have a decoded stock price, which actually has values in it. Oops, here. Okay, so we've got client code which successfully connects to the back end and deserializes the information. What we want to do is we want to use this client code and tie it into our UI so we can actually display it on the screen, because that's the purpose. Now, where are we? Let's create ourselves a configuration. Is that the next step? Well, okay, next step is our chart controller is going to want to know about the client code, because it's going to use the client to connect to the back end and display stuff on the chart. Let's just check that's where we are. Okay. Oh yes, I didn't finish setting up the chart, so we have to do that, otherwise we haven't got anything to show. So in our chart, we're going to create a line chart. Let's cheat a little bit, because I didn't really want to type all of that. Okay, So we want to create a line chart. We need to give it a height. We need to give it an x-axis. My x-axis is going to be strings, string values along the bottom. My y-axis is going to be numbers because the prices are going to go up the side. I'm going to generate one of these in here. And this is how I'm going to populate the line chart. The data in the line chart is going to be populated here using the chart controller. So I need to say that this comes EFXML. It has, like I said, it's got string values and number values. And then I somehow need to populate this chart data. I need an initialization method. Initialize. And I need to set up the chart with the data from the back end. So first, we need to set up our chart. We need to add some data to it. This list is a list of series. So if you've got a line chart, you can have more than one line on there, but I'm just going to show one line for the time being because it's the easiest thing for the purposes of the demo. So we need a list of series. This is therefore FXML, FX collections, a list. What do we need to add into here? We need to add some series. So let's add a series, new series. And this series has a list of the data points in that series as well. So this is the series data. This is the list which needs to have all the data that comes from the back end. So let's create that as a field. And what else do we need to do? We should be able to see a chart when we rerun this. Oh, that's not the right thing to run. I need to run this. Yes, so here's a chart. We've got tiny numbers going up the side and some time stuff going down the bottom. Now, this is the thing we need to hook into the client code to talk to or listen to stuff at the back end. So we're going to need a, what do we call it? A web, let's just call it a stock client, which is a web client, stock client. We now need to make this module dependent upon the client code module. We need to import that class, and we need to wire in the stock client as well. I will come back to this. Normally you get an error saying, oh, I can't find the bean, because obviously this is a Spring bean which is going to get wired in. I'm not sure why that error isn't coming out, but let's fix it before the error turns up anyway, because we do need to do it. So we need a configuration in here. This is going to be client auto configuration, which is configuration. We're going to create a, I'm going to cheat here because there's too much typing. We want to return one of these web client stock clients, which needs the web client. And we're going to wire in the web client with your kind of standard Spring configuration stuff there. Okay, so now we've got one of these things. This can be injected into our JavaFX code, and hopefully then we can do something with our client. Like what we want to do is, the whole point is to get the prices for a particular symbol. This is going to be, doesn't matter because it's fake data. This is also going to be the name of the series. We get those prices and we're going to listen to it. So we're going to subscribe to that flux. We're going to listen to all the prices that come in. What do we want to subscribe to it? In this case, the simplest thing to do with just one series is let's just subscribe this controller to it. There's some refactoring to make it a bit nicer, but this will do the trick. So if I implement consumer, I'm going to be listening to stock price. What do I want to do when I get a stock price? Well, I want to update my data. I want to add it to the data on the chart because I want to show it on the chart. So we're going to take my series data. We're going to add new data. On the x-axis, I'm going to use time on the x-axis. To simplify that, I'm going to use stockprice.getTime.getSecond, just because it's prettier than displaying the whole time on the bottom. But this needs to be represented as a string. So let's put this in here: string.valueOf. And then on the y-axis, we want to display the price. So stockprice, getPrice. And that's fine, but actually this is one thread which is kind of listening to the client. This thread is the client listening to the back end, but in JavaFX you have a different thread which is dealing with the UI. So what we want to do is this: when you're updating data that the UI needs, you need to tell the UI thread to go and do that. Now the way that you do that in JavaFX is you say platform.runLater. And then you basically say, like, when you get a chance, UI thread, would you mind awfully going and doing this and then updating yourself so that you can update the UI? Let's see if we get what we expect to get. No, we do not. Okay. Web client, stock client, available, expected at least one bean. Oh yes, of course, because I created the client configuration here, but what I haven't done is I haven't said that this is like reusable. I don't know all the terminology here, but I haven't said this is reusable beans, that if you use this module, you can get all the beans. So the magic incantation is I need to create a meta inf directory. I need to create a file, which is spring.factories. And then I need to say, a lot of the code completion that is inside IntelliJ IDEA, this is not me cheating. Some of it was cheating. Most of it is not me cheating. This is just IntelliJ IDEA doing code completion, like, because it knows what you expect and what is allowed in these files. Let's say, oh, that's not the right one. I want client auto configuration. And so this is the configuration that I want to be able to use from inside anything that uses this. Now, does that work? Yes, great. Okay, so this is the same set of values which is coming from the back end. So we're listening to those values, reacting to them, and drawing things on the UI. So that's kind of fun. We're using the power of Spring to do that stuff, and we're doing everything reactively. Now, I use the word reactive because it's the buzzword, and that's what we all came here for, right? Now we're doing things reactively because I said so. Now, what you want, you probably heard a lot in this conference that if you're really doing something reactive, you want to be using RSocket. Like, who's heard of RSocket? Good, I'm glad. I spent like 2 weeks researching it, so I'm glad we've got time to talk about RSocket. So what this means is we've been using, let me show you. We've been using REST. We've been using our normal way of doing like streaming values and connecting using the web client. What we want to do is we want to use a protocol which has been designed from the ground up to do reactive stuff or something, and it's got R in the title, so it must be reactive. So instead of doing the web client way of connecting, we're going to do things with RSocket, and you're going to see how vastly different this is. Spoiler, you can go to sleep. It's not vastly different, but it is quite nice because this is all new in 2.2.0, I think. So this is what's kind of interesting, because when I did this with Josh last year, none of this existed. So instead of the REST controller, I've lost track of where I am in terms of the, ooh, don't look at that because you'll see that I haven't dealt with wrapping problems. I have in my code in GitHub. Right, so where are we? We wired up the UI to the client. Yes, perfect. We're on the RSocket server API. Now, that means I need a new controller for my RSocket backend. I'm going to have a controller. This is going to be a RSocket controller. I'm nothing if not predictable. And I'm going to need something similar. So we're back on the Kotlin side of stuff here. I'm going to need something really similar to our REST controller. I'm just going to call it the same thing. Price is 4. It's going to take a symbol, which is going to be a string, and it's going to return a flux of stock price. So far, so not very surprising. And also the code we want inside here looks suspiciously like the code here. So why don't we just kind of put that into a reusable service? So let's get it from a price service. Oh my goodness. Price service. One of the things I like about the IntelliJ IDEA support for like code completion and stuff generally, but specifically for Kotlin, is I'm not super familiar with the Kotlin syntax. So when it says, like, what do you want to do? Do you want to create a constructor parameter? I go, yes. What does that mean? But okay, let's do that. This is kind of tiny. And I say, look, this is the kind of price service. This is the kind of shape of what I want it to look like. And then it goes away. Yes, I know. I don't care, that's the point. It goes away and does what needs to be done in terms of constructors in Kotlin. So that's cool, because I didn't really know how constructors in Kotlin worked. Now I'm just going to create myself a new class called price service. I'm going to put it inside here. This is shockingly, this is a service. And then I'm going to say, I don't know, get prices. I'm going to give it the symbol. I'm going to return that, and I will get IntelliJ to generate this method. Great. Now I know what this is supposed to look like. This basically is all of this code here. So let's take that. Let's shove it in here. Place it gently in there. And then I'm going to move my generate random price to there as well. So then my price service has all my reusable code from both of my controllers. This is just good practice. What else do I need to do? Now, this is Kotlin. Well, let's fix this up as well. So obviously I want something really similar up here, and I want to do the same thing here. I want to create this as a constructor parameter. This is going to be a price service, which now exists. And so everything is nice and happy. This is Kotlin, so we like to try and get rid of boilerplate, so we can remove this, convert it to an expression body, and get rid of the return type. I've been doing Java for 20 years. I've been doing Kotlin for about 3 months. This is magic to me. I don't even know what it means. But the point is that I just basically don't need an awful lot of this stuff. I can just get rid of that and that. Because basically, my method delegates directly down to this method. So I just don't need any of that rubbish like curly braces and stuff like that. It's just kind of saying, this is the same as this. And the last thing I need is I also need a message mapping. The same as we had get mapping on our REST controller. Let's find my POM. Let's put in my RSocket dependency. RSocket. Import that, and then I'm going to do something similar to my REST controller, and I give it basically a location to attach to. So I'm going to call this stock prices, because I'm really original like that. All right, and then, there's one more thing I need to do. I need to tell it where to start the RSocket service, because it needs to start somewhere on the back end. So down in my application properties, I'm going to say put it on port, RSocket server port. Let's put this here so it doesn't get in the way. 7,000. And then I'm going to restart my service. And then if you look, now I've got netty on 8080, which I had before, and an RSocket netty as well on 7,000. So I've got two services, two server APIs kind of like to connect to on the back end. So that's fairly straightforward. That's the RSocket back end API. Now we need to create a client to connect to it and consume stuff the same way we did for our web client. Let's go back to our client code. So I'm going to guess that my client code is going to be fairly similar to my web client, stock client, because that's what I would like to see. So let's extract an interface. Extract interface. I'm going to call the interface stock client. I'm going to bring this prices4 method up. Yes, I would like to use the interface. Oh, I've done something not right. I would like to use the interface everywhere where I was previously using the web client stock client. Just make sure that works. Okay, yeah, so now my chart controller is using the stock client interface, not the web client stock client. Okay, so let's go into our auto configuration, and I'm going to want a stock client, which is the RSocket one. Stock client, RSocket, stock client. What does this look like? Well, I'm going to need a new RSocket stock client, whatever that is. I need to create one of these, which is obviously going to implement stock client. Let's create our methods. Now, if we look at our web client, stock client, that's where we used web client to connect to the backend, retrieve, and create the flux of stock prices. The RSocket stuff is kind of fairly similar. I need an RSocket requester. RSocket requester. Oh, every time. Thank you for being so smart. I need to add it into my Maven dependencies, of course, because we did the server, we have not done the client. And we're just going to give Maven a bit of a poke. All right, Maven, you see your new dependencies or not? Yes, thank you. Top tips there. Ooh, look, low memory. Don't look at that. Everything's fine. The new version of IntelliJ IDEA is much more efficient than the old one. Right, so what I'm going to do is I do something really similar to what I did with my web client. My root was, what did I call it? Did I copy it? Because that would be really useful. No, I didn't. I called it stock prices. IntelliJ being a bit too smart. I don't want one of those. I want to do, what else do I want? I want to send it the data, which is the symbol that I'm looking for. So that's the symbol. And I want to retrieve a flux. And the flux is a stock price. And I can do all the same stuff I could do with the other stuff. So I could set my retry back off policy, and I can do my on error stuff as well. So I can set all those things up too as well, the same way I did with my web client flux. And then we need to wire in one of these, whatever this is. Yes, just do the magic thing. And then this is the bit that sometimes doesn't work. So I want an RSocket requester. That was a magic cheat that I created for the demo. Obviously, IntelliJ doesn't magically know about those things. I want an RSocket requester. In order to get one of these, I need the RSocket requester builder. And the builder, I tell it where to connect on what port, and then I return one of those. So it's a little bit similar to how it works for the web client as well. Let's add that as a parameter and hope that Spring finds everything and wires it in magically. And of course, now we have two beans which look very similar. So I'm going to simplify this with profile. So this is like server sent events, and this is RSocket. And let's say on my client code, I want to use active profile. I'm going to say RSocket. And then hopefully, when I restart my chart, well, the downside is hopefully everything works the same way it worked before. So from your point of view, it looks exactly the same as before. We'll put some logging in there perhaps to see if we are doing the same thing as before. So we're still getting the prices, we're still responding to them, we're still drawing them on the UI. let's see, which following profile? The following profiles are active RSocket. So is there a way to show that we are definitely using the RSocket code? RSocket client. Well, we could log it, couldn't we? We could, no, let's do that here. We could log and say, this is our socket, which the other one does not have. So when I reboot it, restart it, there we go. So now you can see that we're using the RSocket client. So I'm actually astounded because this demo happened way faster than normally when I was practicing. So we could do some other bits and pieces to refactor some stuff. I've definitely got time to take questions now and then explore some other stuff that might seem interesting. So yeah, I've got time for additional refactoring. I didn't expect this. Right, any questions at this stage in the presentation? Yes? Any reason why the client is in Java and not in Kotlin? That's an excellent question. I could give you I could give you two different answers. One is by doing one in Java and one in Kotlin, you can tell the difference between the client code and the server code, so it's a bit less confusing in terms of where am I now. But actually the pragmatic solution, the pragmatic reason is because when I co-presented this with Josh Long, I was doing the Java side of stuff and he was doing the Kotlin side of stuff. So it made it easier to keep things separate. But it's also to kind of show that you can kind of obviously interact between the two things. Sorry, no technical reason. No, it could be whatever. I wanted to kind of play around with JavaFX. There's like JavaFX stuff you can do with Kotlin, but honestly, the learning curve for that was just too steep to try and start doing that side of things. But certainly the client code could easily be in Kotlin, and one of the things I'd really like to do is convert it to Kotlin and see like how much shorter it is, because I expect it to be a bit more succinct, although there's not loads of code there anyway. More questions? Yes?
What's the pro of using the RSocket implementation?
What's what?
What's the pro?
What's the pro of using the RSocket implementation? I was really hoping that lots of people at this conference were going to say the answer to that question. It's designed for reactive implementations. So the web client stuff, let's have a look at the server. The web client stuff is basically using an existing protocol in a way which was not originally designed to do. I mean, it's fine, it works and all the rest of it, but it's just kind of overloaded with a bunch of different stuff. RSocket is specifically designed for reactive connections at the network level. I expect it to be faster, but it's definitely, there's less configuration because that's what it's meant to do. You're meant to stream stuff over it. It's not kind of abusing the request response side of HTTP. Yep. You want the auto configuration, you want to explain that? Good. I'm kind of glad you asked that and also kind of sad you asked that. I did Google this. So the idea being, make it so it doesn't compile anymore. So what we had is, on the client side, I made it, they're two modules. They're basically independent modules, effectively, because they're their own Maven modules. What I found out about the client auto-configuration stuff is that you could have a reusable library like this, where it's designed for you to share the beans. So the Spring Beans are not just kind of sat around used by that code. It exposes the Spring Beans to anything which uses that library. So you're basically bundling up a series of reusable beans. It doesn't work unless you do the Spring Factories thing that enable auto-configuration stuff. So this is basically, the client code doesn't have any meaning other than to be used inside something else. It doesn't stand on its own. It's just a reusable library. Does that it doesn't really answer the question there, does it? Basically, the magic incantation here allows you to deploy something or give something a series of beans that can be used by some other application, Spring Beans. I have got on here, by the way, This is a link to a page on my blog, which is basically like all the stuff I Googled to put this together, and it includes a whole stuff about the client auto configuration stuff, because that's a whole topic and a whole tutorial in its own right. So there is a link to explain about how to use that and why you use it from that page. Any more questions? I would like to do some more refactoring, so you don't have to feel compelled to ask questions. All right. So there's a few more things we could do. One of the things that I would like to do, there's some simple things. Some of them are a bit stupid, but like they just make me happy. One of the things that I don't really like about this code is the chart controller is a controller to control the chart. But the idea is like you've got a one-to-one mapping between the controller and the chart itself. We also here, we actually have a one-to-one mapping between the chart controller and the series of data, which I don't really like, because if you want to add another series of data, then you end up having to, you can't do that here because we're only one consumer of the prices. So we could go through an exercise of trying to actually add a second series of data so we can see two lines moving, and we have two connections to the back end and two sets of streaming data responding to those things. So I would like to try and do that. If anyone doesn't want to see that, I will not be offended if you leave at this point, because the majority of the point of the talk I have covered already. Fine, everyone's like too bored to leave. Right, so conceptually, what I would really like is, I don't want my chart controller to be listening to the stock prices from the back end. I want like a stock prices consumer to be listening so that I can have more than one of those things. So let's start by creating one of those. I haven't practiced this as much, so this will be interesting. So let's say that we have let's have a new stock price consumer. We're going to want to give that a symbol, because the stock price consumer does have a one-to-one mapping between it and the prices, you know, the symbol of those prices, the stock price. Let's create an inner class, because it's easier to see. And I want this to, I'm going to have this implement this. So this is the thing which is going to accept the stock prices. So this is the thing which is going to have to manage the data of the series on the chart. So I'm going to move this series data down here, and also this bit where we manipulate the series data. There are better ways of moving this stuff around, but this is the pragmatic approach. Okay, so we want our symbol, we want a field for the symbol. And we're going to subscribe, let's call this price, what do we call it? Price is 1. What else is duplicated between the series? Well, the series itself, I expect, is duplicated. So this is a series. I want this inside here. Private. Where are we going to get that from now? We're going to get it from here. Price is 1, .get series. Let's return the series. Now, what else have we got? We can inline that because we don't need that anymore. And we have data, symbol. Can we inline that? Well, we could do, but I have 2 new stock prices consumers. That's not good. Right. Now I'm going to subscribe the consumer in there. Well, I would like to fold what else do I want to fold in here? Where's the symbol? The symbol appears twice. I don't really like that, but we can deal with that anyway. So hopefully, let's just restart this and see if this still works. And to test whether it's doing the right thing, illegal forward reference. Ooh, exciting. It's not that exciting, but it's just not an error I see very often. Come on, Okay, cool. So that still works. That's good. And now the point is to be able to have more, to subscribe to more than one symbol. Now, let's see. I've still got duplication there, which I don't really like, but let's inline that. I'll get there in a minute. So we're going to need 2 consumers if we want to do 2 sets of prices. Let's call that 2 to be really imaginative. We need to add the second consumer series to that, and we need to subscribe the second subscriber. This is going to be, let's call this, let's be really imaginative and call this like symbol 2. Where else are we using that? Okay, now, there's still duplication. I would still like to refactor that, but I don't want to spend forever doing that. So now we've got 2 sets of data. So we've got we have one client making 2 separate requests for 2 different sets of data. I have a really horrible name down there, but that doesn't really matter. So now we can actually, this belongs in its own separate class, and then we just have to add as many of these consumers as we want for each one of the prices. That's one lot of refactoring I wanted to do. And are there any more questions at this point in time? Honestly, like I ran through this yesterday, it was a 70-minute presentation. I must have got really fast at doing the demo. Any more questions, any comments, anything you want to try? Yes? Is there a way to demonstrate back pressure on our socket? I really like the idea of that, yeah, because the whole point is it should deal much better with things like back pressure. So I can't do it here because what I would like to do is I'd like to set up a consumer which is particularly slow and a producer which is really, really fast. I mean, theoretically, I suppose I could set my service up so it doesn't tick every second. It could tick every millisecond and have the client tick really slowly, but I don't know how long that would take. And I don't know how it would blow up, because when I've experimented with this stuff in the past, FlatMap does interesting things if you don't understand how back pressure works. You sometimes don't see errors, you just see it going, yeah, everything's fine, but nothing happens. So yeah, I think that would be an interesting experiment. 10 minutes, goodness me, I was really panicking I would run out of time. Yes?
How does IntelliJ do with following this app as a self-contained?
How does IntelliJ, sorry, I didn't catch that. How does IntelliJ deal with?
Following this as a self-contained Java application where I don't need to, with JavaFX, you can bundle the app with JRE.
Yeah.
Can IntelliJ do that? With this app?
IntelliJ doesn't have the built-in capability to, you want to create a deployable artifact, is that what you're saying, with the JRE? Yeah, with JLink, exactly. Yeah, no. At the moment, IntelliJ does not allow you to utilize JLink to create a bundleable application with the right parts of the right modules of the Java runtime. No, it's not built into IntelliJ yet. There is a ticket for that though, so feel free to go to the issue tracker and upvote it or add comments on how you'd like to see that. I think it would be, so for context, in Java 9, JLink came in. JLink is the ability to allow you to pick just the bits of Java that you're interested in, and then you can bundle that with your application and create a deployable which includes Java. But instead of having the whole of the JDK, you just have just the bits of Java that you want. That was sort of the point of modularization, but it isn't well known. And part of the problems with JavaFX is that there's no longer a JRE since Java 11. There's no longer a JRE. So you can't bundle it with a JRE. You have to bundle it with JLink artifacts. And yes, that's not currently, it's not a button that you can put inside IntelliJ that says, do that for me. It's a manual process.
How about the Spring isn't modularized? It hasn't been modularized, which is I just tried it the other day. It was nearly.
Yeah, modularization is interesting. I have other talks on modularization. The reason why you have to do this funny thing here, where you have, no, where is it? It's on where you have a chart application, which is a JavaFX application, and a separate application to launch it, is for modularity reasons. Because I'm using Java 11 and I'm using JavaFX 13, no, I'm using Java 13, JavaFX 13, and so it just kind of, even though I'm not using modularity, even though I'm not using the module path, even though I'm trying to go the class path route, it automatically assumes that I want to use modules, and then it falls over because I haven't set up the module stuff. So you can fake it into doing this. Yeah, modularization is an interesting thing. It does have benefits like the ability to use JLink, but modularizing an existing application, I would not recommend doing it unless you have very good reasons to do so. Any more questions, comments, things you want to see? Yes?
So I'm brand new to RSocket, and so I'm more curious about the ways that you attach messages to RSocket and maybe deserializing objects by sending those. Can you do that?
So there's not a lot of demos or documentations on RSocket yet, as I discovered when I was trying to put this together, because it's the API, the current API is new in 2.2.0. And in fact, if you look at the different milestone releases, the API changed between milestone 2 and milestone 6, which was a lot of the tutorials are in milestone 2 and they don't work in milestone 6, the release candidate. So that's a long way of saying I don't really know how it works because it's not currently extensively documented and the tutorials don't really cover that. I can tell you that what I saw, that when it finally worked, so I am passing data to the back end using this. I'm passing the symbol to the back end, and I'm obviously retrieving the flux of prices, the stream of prices. I did have trouble with the serialization and deserialization. It did say to me that I think it was, I don't know if it was stock price or one of the fields. It was like, I don't know what that is. Oh, double. I don't know how to deserialize double. I was like, how can you not know how to deserialize double? So, like a lot of Spring stuff, when it works, it just works magically. When it doesn't work, it's quite difficult to track down what needs to be done. The main way that the serialization works nicely and magically is when your client-side data object matches exactly your server-side data object, the same as any JSON type thing. So yeah, I'm not sure about all the ins and outs of it. It was a little bit tricky, and there aren't a lot of resources at the moment to see examples of how it all works together. However, on this page, I have like a link to like 6 or 7 RSocket tutorials because that's what it took to build this application. This is one of those things where like when you see it working, it's like 3 or 4 lines of code. It looks really easy, and it takes like 3 weeks to put that together because it doesn't work most of the time. Any more questions? Great, oh, sorry, there's one there. Yes, so if you go to that link, the code is on GitHub. So there's a link to both the client and the server code on GitHub. Yeah, so hopefully everything you need should be there. This has been a very useful session. You've had very sensible questions, and it's been great to be able to actually explore some of this stuff and do more than just like the set live demo that I wanted to give. So thank you very much.